Hey everybody. This is an intro to right triangles and trigonometry. This will be really easy, really brief. If there is anything that you want to write down, you might want to go grab some paper and pencil. You can pause and take screenshots, whatever you need to do. These are just a few things that I thought you might need to know to help you be successful ACT or your next math class, some things we didn't get to cover. So, the first thing I want to talk about is the Pythagorean theorem. There's two pictures of right triangles right here. You use the Pythagorean theorem to find the missing side of a right triangle. Sides A and B are called the legs, and side C is called the hypotenuse. The hypotenuse is the longest side. It's also going to be the side that's straight across from the right angle, so the side that is not touching the right angle. The formula that you use with the Pythagorean theorem to find the missing side of a right triangle is a squared plus b squared equals c squared. So you square both of the legs, add them together, and they should equal the hypotenuse right here. All right, so we're going to practice a couple. Like I said, paper, pencil, if you want to write it down, pause the video anytime you need to. The right angle is right here. So the 22 and 27, those are both legs. That's going to be A and B. It doesn't matter which one you pick as A or which one you pick as B. They're interchangeable. And then right here, X, that's going to be the hypotenuse. So here's our formula. A squared plus B squared equals C squared. And here is our numbers placed into our formula. If you have your calculator on your phone or just another calculator, you should be able to easily find the squared button. And if you can't, you just do 22 times 22, and then you'll get your numbers. So square both the 22 and the 27. You get 484 and 729. And then add those two together, you get 1213. That's C squared. But since I'm looking for this side, remember that's just C, not C squared. So to get C and not C squared, you're going to take the square root of 1,213. That is the inverse of squaring something, so that button should be close to the squared one on your calculator. And the square root of 1213 is 34.8. So this missing side right here is 34.8. The next one, I have this one here that I'm missing. That's a leg. This is also a leg, and here's my hypotenuse. So I'm still using a squared plus b squared equals c squared, but now I'm looking for one of these legs instead of the hypotenuse. You can name this one that's missing A or B, doesn't matter. I chose to name it as A, and I plugged in the X there just because it says X, but you can leave it A, it's not a big deal. And then I put in my 19.1 and my 30.5, and they both have their squareds. So I squared both of those numbers. And then, since this is with the x squared, you have to subtract the 364.81 from this number to see what's left. You get 565 and 44 hundredths. And then do like you did before, take the square root to get just x by itself, and you should get 23.8. The next thing is classifying triangles using the Pythagorean theorem converse. So if you don't want to write all this down, maybe once we get all the notes up here, screenshot it and you'll have it. The first thing is, if you have a right triangle, or any triangle, and c squared equals a squared plus b squared, then the triangle is a right triangle. If c squared is greater than a squared plus b squared, then the triangle is obtuse. And something to note, c is always going to be the largest number or the largest side. And then the a and b are going to be the two smaller ones. If c squared is less than a squared plus b squared, then the triangle is acute. And when you're classifying a triangle, I'm going to show you how to set this up in just a second as best I can. Keep c squared to the left to keep yourself from getting confused. And the last thing, remember to determine if the three side lengths form a triangle before you try to classify it. I can't remember how long ago we did this, so just a refresher, to find out if something is a triangle or not, you take the two smaller sides, add them together, and make sure their sum is greater than the third side. So I'm going to do one with you and show you what I mean by that. Determine whether the following sides create an acute, right, obtuse, or no triangle at all. My three sides are 3, 8, and 9. So the first thing I want to do is decide if this is even a triangle. So to do that, you pick the two smallest, so 3 and 8, and add them together and see if that sum is greater than the third side. So 3 plus 8 is 11. 11 is greater than 9, so this is a triangle. Since it is a triangle, I need to decide whether it's acute, right, or obtuse. So a second ago, I said make sure you keep c squared on the left to keep yourself from getting confused. In this case, c is going to be 9 because that's the largest number. So I have c squared, and I'm comparing it to a squared plus b squared. This is going to help me know whether this is acute, right, or obtuse. So I've got everything with the squared, and I'm going to go ahead and square everything. So 9 squared is 81, 3 squared is 9, and 8 squared is 64. Add these two right here together, and you get 73. 81 was c squared, and 81 is greater than 73. That means c squared is greater than a squared plus b squared. And you can reference your notes back from the previous slide, because I know this is all new. But since c squared is greater than a squared plus b squared, this is an obtuse triangle. All right, I've got 3 more for you to practice. So what I'm going to do is pop the numbers up on the screen. I want you to pause it. See if you can figure it out yourself first, and then resume it and see if you got it right or not. So the first one is 3, 10, and 14. So pause the video, work it, and then resume and see if you got it right. Three plus 10 is 13. Those are the two smallest sides. And 13 is less than 14. In order for this to make a triangle, the two smaller sides added together have to be larger than the third, and they're not, so this does not even make a triangle at all. So the answer here would be not a triangle. All right, the next one I want you to try is 17, 17, and 22. Pause the video, work it, and resume and come back. First thing I did was check to make sure that this was a triangle, and it is. Then I set my problem up so c squared is on the left, and I'm comparing it to a squared plus b squared. Here's my numbers I get when I square them. And then 484 is less than 578. Therefore, c squared is less than the sum of a squared and b squared, so that makes this an acute triangle. The last one I want you to try is 18, 24, and 30. This does make a triangle. The two smaller sides added together are greater than the third. Here's my numbers. I forgot to change these 2's to squareds, so just know that this should be squared, 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 not 302, 182, 242. After I square them, We get 900, 324, and 576. And then 900 equals 900. So c squared is equal to a squared plus b squared. That means this is a right triangle. Now, if you're picking up your paper packet from school, there is some practice on this in your packet. It's a maze. I think there's 2 of them. So, that does not have to be turned in, but it is practice for you to get better at this. If you have questions or need help with something, just take a picture of it, shoot me a message on Remind, and I will respond to you as soon as I get it. The next thing I want to talk about, and this will be the last thing for now, is trigonometry. And we got none of this covered when we were together in class, so this is going to be very simple, very brief. I just don't want it to be a foreign word to you. So trigonometry is the study of triangle measurement. Now, this goes way deeper than what we're going to talk about right now. And we are only going to work on right triangles at this time. So each acute angle of a right triangle has the following ratios. So obviously a right triangle has one right angle, but the other 2 angles are acute, and those 2 acute angles have special ratios. There are 3 of them right now. The first one is sine. Sine is the ratio of, so right here with sine, we're going to be talking about an angle, the acute angle. And then the opposite and the hypotenuse, those are the sides. So the side opposite that angle and then the hypotenuse of the triangle. The next one is cosine. So that will be the side adjacent to that angle and the hypotenuse. And then tangent is the last one. That will be the side opposite the angle and adjacent to the angle. And this will make more sense in just a minute when we start doing some with actual numbers and pictures. So don't fret if it seems foreign for right now. Something to remember is SOHCAHTOA. I know that sounds silly, but it helps me remember. There are probably thousands of mnemonic devices if you want to Google something that you think is funny or silly or whatever to help you remember. But you definitely need to know those 3 trigonometric measures and what they mean. All right, so what we're going to do is find the sine, cosine, and tangent of both acute angles on this triangle. So I have this angle A, which is acute, and this angle B, which also is acute. You cannot do this with the right angle, so ignore it for now. Just know that it's there denoting this is a right triangle. Also, this picture is not to scale. I know that this and this aren't that much of a difference, and that's a 5 and a 12. It's fine. So first, I want to find sine A. So here's A. This is my angle. And remember that sine is opposite over hypotenuse. So angle A, the side opposite that is going to be right here with a 12. And then the hypotenuse is always what's straight across from the right angle. So that's 13. So to find sine A, for right now, all you have to do is just write the 2 numbers, 12 over 13. And you can write this as a regular fraction like we do in class. I just wasn't sure how to do that on here. But that is a fraction bar. So 12 over 13. That's it. Opposite over hypotenuse. Cosine A is going to be the side adjacent to the angle and the hypotenuse. So I know hypotenuse is 13. That's going to be my denominator. Adjacent is the one that it's sharing a side with, the one that it's touching. Well, it can't be this one here because that's the hypotenuse, so it has to be this one. So that is 5. So adjacent over hypotenuse is 5 over 13. And then the last one is tangent. Tangent, I'm still talking about angle A, tangent A, is opposite over adjacent. So opposite would be 12. That's the side opposite this angle. And then the side adjacent to the angle is 5. So tangent A is 12 over 5. Now I want you to pause the video and I want you to find sine B, cosine B, and tangent B. and then resume the video and make sure that you have gotten the correct answers. Sine B is opposite over hypotenuse, so 5 over 13. Cosine B is adjacent over hypotenuse, so 12 over 13. And tangent B is opposite over adjacent, so 5 over 12. All right, I've got one more I want you to try. I want you to find sine, cosine, tangent for A and B. I'm going to do the first one with you just because I want to show you something. Here's A. Sine A is opposite over hypotenuse, so that's 30 over 34. But if you'll write 30 over 34 down on your paper for me, you'll realize that that fraction can be simplified. You most definitely, please, do need to simplify that. So 30 over 34 simplifies to 15 over 17. So pause it, find cosine A, tangent A, and then sine B, cosine B, tangent B, and come back and check with me and make sure you got them right. Cosine A is 8 over 17. Tangent A is 15 over 8. Sine B is 8 over 17. Cosine B is 15 over 17. And tangent B is 8 over 15. All right, that's going to be the end of this video. I know that was very quick, very brief, especially with the trig, very simple. There is no practice in your packet for the trigonometric ratios. I just wanted to show you that so you'd have some sort of base knowledge. Like I said before, any questions, concerns, whatever, shoot me a message on Remind, and I will be glad to help you. Here's my references. That's where I got my pictures. Just want to give credit where credit's due. Thank you.